Alright, in today's video, we're going to look at making equivalent expressions. Now, there's a couple things to think about when you're getting ready to do this. First, you want to find a common factor for all the constant terms. And once that common factor has been found, then you want to write an expression using one of those common factors as the shared term within the distributive property. All right, so that second one might seem a little bit confusing, but once we take a look at some examples, I think it'll all make sense. So let's look at our first example. Say we have the expression 6m plus 2y. Well, our constants are the 6 and the 2. Now in algebra, they're also called a coefficient since they are the term that's next to the variable. So we're going to take our two constants, 6 and 2, and we're going to find a common factor between them. So if we take our 6 and our 2, and we list out our factors of 6, 1, 2, 3, and 6, and then our factors of 2, 1, and 2. Well, common factor that they share is 2. Now, we could use the 1, but if we break this out using the distributive property with a common factor of 1, it's going to look the exact same. So it won't be equivalent, it will be identical. So let's go ahead and take this common factor, and we're going to write an expression using this common factor of 2 as the shared term with the distributive property. So I'm going to write my common factor on the outside, then parentheses. Now, if I were to take 6 divided by 2, it would get me 3. So that's going to be a 3m. 2 divided by 2 is 1. Well, 1y would just be y. So an equivalent expression to 6m plus 2y would be 2 times 3m plus y. Let's look at another example. Let's take no coefficients, just let's take two constants, 18 plus 8. All right, so let's go ahead and find some common factors between 18 and 8. Start with my 8, 1, 2, 4, and 8. And my 18, all right, so there's my list of factors for each. The common factors, we have 2. Now you notice I don't even circle the 1 because it's not going to come into play when writing equivalent expressions. And so it looks like the 2, once again, is my only common factor. So I'm going to use this 2 as the shared term within the distributive property. So I'm going to put that on the outside. Now, 2 times what gets me 18? Well, that'd be 9. Plus 2 times what gets me 8? Well, that's 4. So an equivalent expression to 18 plus 8 would be 2 times 9 plus 4. All right, let's take one more example. This one gets a little more involved, a little more options. So let's do 12x minus, well, let's go plus again. You could do a minus 36y. So now our coefficients or our constants here are 12 and 36. So if we do our 12s, and then we go ahead and list the factors of 36. 1, 2, 3, 4. 6 is our turnaround. So 4 and 9, 3 and 12, 2 and 18, 1 and 36. Oops, off the screen there. Common factors. Well, once again, I leave out the 1 because that's not going to do us any good here. So let's see. We have a 2, a 3, a 4, a 6, and a 12. A lot of options here. Well, let's look at how we could do this. If we use our shared term of 2, shared factor of 2, we break this down. Well, what times 2 gets you 12? 6. What times 2 gets you 36? 18. So there's one option. What if we use a common factor of 3? Well, 3 times what gets you 12? That would be 4, so 4x. 3 times what gets you 36? And that would be 12. So 3 times 4x plus 12y. Let's use the 4. 4 times what gets you 12? Well, that'd be a 3, so 3x. 4 times what gets you 36? 9, so 9y. So all of these are equivalent. Okay? They don't look exactly the same, so they're not identical, but they get you the same outcome. And you could continue on with writing it using the 6 and the 12 as well. So the idea behind writing equivalent expressions is find a common factor for all the constants. Sometimes it's a coefficient, where it's next to a variable in this case, or sometimes it's just a constant term, such as in this case with no variables. Now once you have found the common factors, then you write an expression using one of those common factors as the shared term within the distributive property. All right, hope you learned a lot. Good luck.